So yesterday's session we have discussed about Fourier series for even and odd functions. So today also we are going to discuss a similar same concept, function Fourier series defined in the interval minus pi comma pi. So few more important questions are there. So I have forwarded the three different documents to you. So now it is showing on the screen. The other one is this. I have written something with the different pens clearly, and I have sent already sent this one more soft copy. Just you go through all the three. If the question is not solvable in any one of the document, you go to other document. You can see all different questions we have been solved in the different done. So here in this we have very less few answers are there. Here few different questions we have been solved, that also have been put it in the group. So these three documents based on the requirement you go through it, right? If you see the question, this type of question is little important, like mod x, mod sin x are discontinuous. Like, see the question, obtain the Fourier series for the function f of x is equal to mod x in the interval minus pi comma pi, and deduce that this series. So first we understand provided function. If it is defined in the interval, if it is defined in the interval minus pi comma pi, the first thing we need to be do, for the first thing we need to be do, is it even function or function? So once we decide the even and odd function, just yesterday we have discussed, if it is an even function, just we are going to find a naught and an only, bn will be 0. If it is an odd function, so a naught, an we are going to be get 0. So bn we need to find, that will be sufficient. So for that reason, just I'm using that property and we are checking provided function even or odd. Okay, provided function f of x is equal to mod x in the interval minus pi comma pi. So first we check provided function even or odd. So for that reason, just I'm putting x is equal to minus x. So I'm substituting minus x in place of x is equal to minus x. So mod minus x will be nothing but mod x only. So I've taken f of minus x. The result is f of x only. So therefore the provided function is even function. You know, everyone know well, mod x is an even function. So even function. If it is an even function, obviously we are going to have a naught and an only. Bn will be 0. So that formulas are a naught is equal to 2 by pi integral 0 to pi f of x dx. An is equal to 2 by pi integral 0 to pi f of x cos nx dx. So bn will be 0 because provided function is even function. So in the even function we'll get only a naught and an's only. So therefore we are not going to be find anything bn. So therefore the Fourier formula, it consists of a naught and an's only. So that's what here the Fourier formula becomes f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos nx. So a naught is equal to 2 by pi integral 0 to pi f of x. So f of x is nothing but provided function is mod x dx. So 2 by pi mod x is nothing but x only in between 0 to pi, all positive numbers, the mod x function react or act as x only. So x dx. So integration of x is x square by 2 and the integral limits 0 to pi. Substitute that respective limits, pi square by 2 x is equal to pi upper limit minus lower limit. So pi square by 2 minus 0. So 1 pi get cancelled, 1 2 get cancelled. So therefore the leftover term is pi. So therefore a naught is equal to pi. Similarly, we need to be find an. So an is equal to 2 by pi integral 0 to pi f of x cos nx dx. So f of x is provided function mod x cos nx dx. Since mod x is x, because it's all numbers are positive, so therefore mod x becomes x cos nx dx. So here the two functions. So therefore we apply chain rule. So x is nothing but u and cos nx is nothing but v. So chain rule is u v1 minus u dash v2 plus u double dash v3 so on. So the formula u is x as it is. V1 is integration of cos nx. So integration of cos nx is sin nx by n minus u dash. U dash is derivative of u. So u is what? X. X derivative 1. X derivative 1. So if x derivative 1, this will be v2. So this is v1. V2 is nothing but integration of v1. So integration of sine is minus cos nx by n. So already one n is there, n into n square plus u double dash. So u dash is already there here. So u dash 1 derivative 0. 0 into something is 0. So therefore we are stopping this process like u dash u double dash. So this is v1 v2 so on. So this all u is vanishes, so therefore we stop the process and the limits are 0 to pi. And here this term directly I cancel 0, since it is, if you take substitute upper limit pi, so it will be sin n pi. Sin n pi is 0 minus, if we substitute lower limit is 0, sin 0 is 0. So if any sine function, it consists of 0, pi, minus pi, 2 pi, for all the values it will be 0. Sin n pi is 0 for all n. So only the leftover term is the second term. So minus of minus, it will be plus. So cos nx, this n square I have taken out. So therefore 2 by n square into pi. So cos nx, substitute the limits. So upper limit is cos n pi. So cos n pi we know very well. So cos n pi is nothing but minus 1 power n minus, if you substitute the lower limit, so lower limit is cos 0. So cos 0 is 1. So cos n pi is minus 1 power n, cos 0 is 1. Now based on this value, the complete value will change, but basically n is sufficient, but in the question also deduce that. So that's the reason why just I'm checking where we are going to be get this. So where we are going to be get this 0 or 1. So for that just I'm taking n is even, minus 1 power n is there here. If n is even, this will be 1. So 1 minus 1, 0 will get the result. So if n is odd, minus 1 power n will be minus 1. Like n is odd in the sense minus 1 power 1 will be minus 1, minus 1 power 3 minus 1, like. So minus 1 will get minus 2. Minus 2 into 2 minus 4 by pi n square. If n is odd, we are going to get this. So therefore what it means, we are going to get 1, 3, 5, 7 like that. So this an is defined when n is equal to odd numbers only. So that's the reason why here I have clearly mentioned substituting this completely in the Fourier series formula. If you see left hand side, f of x is nothing but mod x. F of x is nothing but mod x is equal to pi by 2 plus summation n is equal to 1, 3, 5. Look at here. If n is odd, therefore only we are going to get some result. If n is odd, this result is 0. That's what clearly I'm mentioning. it will be defined n is equal to 1, 1, 3, 5 on 1, 3, 5, so on. So therefore the result is minus 4 by pi n square cos nx. Summation n is equal to 1 to infinity a n cos n, where a n is nothing but this. So there is no bn. Bn will be 0. Already we know it. So therefore this result is mod x is equal to pi by 2 minus 4 by pi. I'm taking n is equal to 1. So if I take n is equal to 1, so therefore it will be minus 4. I'm taking already out 4 pi. So therefore 1 by n square. N is equal to 1, 1 square. So I'm taking n is equal to 1 cos nx. I'm taking n is equal to 3 second term. So 1 by 3 square cos 3x. I'm taking n is equal to 5. So 1 by pi square cos 5x, so on. So like this, we are going to get that respective series. Now deduce the series is, look at here, left hand side, what value if I consider to going to get the series, just you try it. That's what I have left for you. Put x is equal to 0. What are the possibilities? Just you think it. The provided interval, the provided interval is minus pi comma pi. Just substitute randomly minus pi, pi minus pi by 2, minus pi by 2, 0, pi by 2, plus pi. Like that you simplify. The only thing, if I substitute minus pi by 2 and plus pi by 2, look at here. So cos pi by 2 is, cos pi by 2 is 0. So therefore these two is not applicable to get this series. So the leftover terms minus pi, 0, pi. Just you try to substitute in this, and which is suitable to the to get that series. Just substitute that respective value and deduce that respective series.